name is T. Padma Pavani. I am from CSM branch. Today my topic name is implementation of queues using array with example. Introduction to queue implementation using arrays. Queues are a type of data structure that follows the first in first out principle. Arrays can be used to implement queues efficiently. In this presentation, we will explore how queues can be implemented using arrays with a practical example. Here we can see the rear and front. In queues, there are two ends. One is rear and one is front. We can add an elements from rear and we can delete the element from front. Basic operations in a queue. The basic operations in a queue include enqueue, add an element to the rear, and dequeue, remove an element from the front, and is empty. Check if the queue is empty. These operations are essential for maintaining the order of elements in a queue. By using arrays to implement queues, we can perform these operations efficiently. We can observe in the diagram enqueue operations. Here, from front, we can add 17. In step 1, we can add 20 at the index of 5th. Initializing a queue using an array. To implement a queue using an array, we need to define the size of the array and initialize variables for front and rear pointers. The front pointers points to the element at the front of the queue, while the rear pointer points to the element at the rear. Initially, both rear and front and rear are set to -1 to indicate an empty queue. Enqueue operation in a queue using an array. When an element is added to the queue, enqueue operation, the rear pointer is incremented by 1. The new element is then inserted at the position pointed to by the rear pointer in the array. If the queue is empty, both front and rear pointers are set to 0. See the examples. Here we have front and rear. When we are in queue, we can add here, we add 6. While we are deleting the element from front, we are deleting the number 1 at index 0. Dequeue operation in a queue using an array. Removing an element from the front of the queue, dequeue operation involves incrementing the front pointer by 1. The element at the position pointed to by the front pointer is removed from the array. If the queue becomes empty after dequeuing, both front and rear pointers are reset to -1. Checking if a queue is empty. To check if a queue is empty, we simply compare the values of front and rear pointers. If front is equal to -1, the queue is empty. The front is not equals to -1 but rear is, it indicates the queue with a single element. Example of queue implementation using an array, enqueue operation. Let's consider an example where we enqueue elements 10, 20, 30 into a queue implemented using an array. Initially, the queue is empty with front and rear point set to -1. After each enqueue operation, the rear pointer is incremented and the elements are added to the array. In this example, we clearly observe the enqueue operation of the array. Advantages of implementing queues using arrays. Implementing queues using arrays offers efficient memory utilization. Array-based queues have constant time complexity for enqueues and dequeue operations in most cases. Arrays provides random access to elements allowing for easy traversal and manipulation of the queue. Conclusion. In conclusion, implementing queues using arrays is a simple and efficient way to manage data following the FIFO principle. Understanding the basic operations and initialization process is crucial for successfully implementing a queue using arrays. By leveraging arrays, We can create robust queue data structures that and in various programming scenarios. Thank you for giving this opportunity.